everyone. I want to continue on with basic geometry review, and we're going to talk about radians. But before we get to radians, let's back up a few thousand years back to the Babylonians. When the Babylonians worked with circles, they divided it into 360 degrees. Now, real quick, this is just based upon their calendar. They fudged a little bit on their numbers, but 360 was such a nice number to work with. They based each day of the year as 1 degree. So as each day progressed throughout the year, this would be 1 degree. And then they came up with 360 days in their calendar, 360 degrees. We inherited that. Completely human invention. Just off the top of, if aliens were to come to our planet and say, hey, check out our circles. We got 360 degrees here, and this is how we work it. They're going to look at it like we're crazy, and they're going to want to blow up our planet. Because we're not mathematically sophisticated. But fortunately, radians comes and saves the day. This is a completely human invention. Radians is a mathematical one based on deductive reasoning. And what we've done is we base the circle. We can subdivide the circle in radians, which a radian is basically the measure of this central angle to where the length of this intercepted arc is equal to the radius. And that just makes mathematically perfect sense to a lot of people. And that's what we're going to use pretty much on all your math classes beyond geometry. So to get used to that, let's think about this. Now, here we basically have a unit circle. Even though it doesn't say it, this is 2 pi. Let r be 1, so this would be 1, 0, so on. And if r is 1, if you remember, the circumference of the circle is 2 pi r. So if r is 1, the circumference is 2 pi. So we start at 0 degrees and go all the way around to 360. Well, we start at 0 pi and go all the way around to 2 pi. Well, half of 2 pi is 1 pi, yummy, yummy pi. I'm thinking lemon meringue. And then half of 1 pi is pi over 2. And that's going to work with this coordinate right here at 0, 1. All right, on a unit circle. Unit circle, again, is with a radius of 1. This works on any circle, though. We just have a scale factor is what's going on. And, of course, 270 is going to be 3 pi over 2, or 1.5 pi, if you want to think of it that way. So when we take a look at this, we've got to get used to our psychology here. We think, oh, pi over 3. Well, that's not quite pi over 2. That's going to be like right over here. All right, whoops, I messed that up. It's going to be in quadrant 1. So it's going to be in 1. 9 pi over 8 is a bit over 1 pi. That's going to be over here. So that's going to be in quadrant 3. And we want to get used to that. And the thing about it is that we can just keep going around and around and around. And we can have really big pies. All right, moving on. So here is a glimpse of our unit circle. Again, r being 1. All right. And these are going to be basically our radians. This is going to be the measure of the degree of theta in a lot of ways. Okay. So we can convert from radians to degrees. All right. And degrees to radians, going back and forth, using a very simple process. Remember, if this is 2 pi, this is 1 pi, this is 180. This 180 is equivalent to 1 pi. That makes a really good ratio. It's like money conversion. So we just simply knock out, say if I want to do, like for instance, 90 degrees. Yeah, I think I got that example on this very next one. I want to do 90 times pi over 180 will give me the radians. Well, 90 over 180 is just 2, so this is equal to pi over 2, which we saw in the unit circle. So we could take any degrees, negative 225. Now let me recap real quick. We do our degrees this way, counterclockwise, and that's going to be our positive degree. So when I say 370 degrees, I'm going counterclockwise all the way around here and stop over here. When I do negative, we're going to do it clockwise. And again, this is a legacy from the Babylonians, the Indians, and the Greeks, and so on. So clockwise, we're going to go the other way, this way. So when we talk about negative 225 degrees, I'm going this way, 225 degrees. So I'm starting here. There goes 90. There goes 180. I'm somewhere over here, all right? So we're going to do negative 225 times pi over 180 and simplify that fraction. So that comes out to be negative 5 pi over 4. Negative 5 pi over 4, which is just right over here somewhere. Okay, And of course, we can take these radians, 3 pi over 2. We already know that answer if you have your unit circle down. And we're going to multiply it by 180 over pi. All right? So the pi's cancel out. And 2 into 180 is 90. 90 times 3 is going to be 270 degrees. Okay. 7 pi over 3. Well, that goes 7 pi over 3. Remember, 3 pi over 3 is just 1 pi. 6 pi over 3 is 2 pi. So we went around a good bit. We went all the way around and we're back over here somewhere. So we're just going to take that, multiply it by 180 over pi. And I bet you I'm going to get a number bigger than 360. All right? So 3 goes in that. 6 times 7 is 42. So we got 420 degrees. Alrighty? So conversions are pretty easy. And you want to be able to do that. Go back and forth because we still do a lot of work in degrees, especially real world problems. We've got to watch out for that word. But in a lot of problems we do degrees because that's how the world operates. Now let me show you this. This is we're gonna kind of leave the unit circle. So if I have a coordinate here, this is going to be my delta y. This is going to be my delta x, and this is going to be a squared plus b squared equals c squared. This is going to be my radius. So the radius is going to be distance. It's going to be a positive distance. This xy can be any coordinate. So let me run through a couple examples on that. So here we have let negative 3, 4 be a point on the terminal side of theta. So let me review another term. So when I talk about going around this way, here's negative 3, 4, okay? And I'm not very drawn to scale here. And I come around this way. This is my reference angle right here. And this is my terminal side of the angle. This is my x-axis. And so we're going to use the reference angle to determine what my sine, cosine, and tangent are. This is actually a pretty important exercise, even though it's straightforward. Now I picked 3, 4. Oh, someone did. I didn't write this problem. Because it's a 3, 4, 5 triple. This is my delta x, which is equal to 3, and this is my delta y, which is equal to 4, and this is 5. So r is equal to 5. So we have our triangle here, my reference angle here. Now the important part is to make sure we're in quadrant 2, okay? And we're going to start looking at the values of our sine, cosine, and tangent. So here for my sine of theta, I have opposite, that's my y value, over hypotenuse. My cosine of theta is going to be adjacent. Now that delta x is 3, but my value is negative 3 over 5. And my tangent of theta, which is opposite over hypotenuse, is going to be 4 over 5. What am I doing? That's not sine. Opposite over adjacent, which is going to be 4 over negative 3. All right? So let's take a look at one more example and I'll wrap it up. Here we have another one. We're going to have negative 7, negative 24 way down here somewhere. All right? Well, way down here. Okay? That is just downright pathetic on my part. So I'm going to do my reference angle, which is right here. Reference angle, this is my terminal side. That's my reference angle, and there's my x-axis. So this is negative 7, negative 24. Now I did this one again because it's a triple. So a squared plus b squared equals c squared. That's going to be 25. So r is equal to 25. And you want to do your sine of theta, which is going to be opposite over hypotenuse. Well, this opposite is negative 24. I'm going to write negative 20. That's not my delta y. That's just my y value. So I'm taking this right here, negative 24, over my radius. And you're going to start seeing a pattern here. I'm not going to need to draw this triangle every time because I'm going to employ this as my sine, and this is going to be my cosine input, okay? And I won't need to draw this picture anymore. So my cosine of theta is going to be negative 7 over 25. And my tangent of theta is going to be opposite over adjacent. So that opposite being negative 24 over negative 7. Okay? negative 24 over 7, which is equal to positive 24/7. So to do the cosecant, cotangent, and so on, I'm just going to flip these. Negative 25 over 24. Secant is equal to 25 over negative 7. 25 over 7. And my cotangent is 7/24. And I believe that is it, I think. Let me take a peek at the next one. Yep, that is it. I'm going to go ahead and get this uploaded and look at the next one.